Good afternoon. This lesson is going to be for Monday, February 1st. So here you can see I'm in Schoology fourth periods folder. All folders should look similar. We have our bell ringer. We're going to do a video Q&A, and then you will be responsible for completing a types of friction mini poster. So first thing, let's begin the bell ringer. So for this one, it says a spring scale is pulled downward and readings are recorded. Notice the relationship between the distance pulled and the reading that is recorded. So at 1 centimeter, it's 4. 1.5, we've increased to 6. At 2, we've increased to 8. And at 2.5, we've increased to 10. So you should observe that there's a relationship. Every 0.5 increase, you see an increase of 2 newtons of force. So if the spring is pulled 3.5 centimeters, it should read, well, if it increases by 2 every 0.5, at 3, it should be 12. And at 3.5, it should in fact be C, 14 newtons. So you're basically looking at the relationship between the increase in distance and the reading for this question. Once you've posted your bell ringer, the next step is for you to watch a video and submit some questions. So these are 10 questions that go along with the video, and you guys are just going to answer them. So for the true and false, you can just highlight. So if you think it's false, you will highlight. Number 2, it says provide an example of force that cannot be seen. You're going to type those responses for these. The same with number 3. For number 4, you'll be filling in the blank. And for number 5, again, you'll be highlighting similar to number 1. So if you see a blank, you will type your response. And if it is true and false, you will simply highlight your response. You will need to submit this activity. So now that I've showed you the questions, I'm going to get ready to share the video with you because this video is embedded in Discovery Education. It's not available for all students to access. So I'm going to get ready and share that link with you now in just a moment. Or I'm going to share my screen with you while the video plays. All right, so here's the video that corresponds to the question. So make sure you have your questions up and listen up as we go through the video.
Some forces will work without being seen by anyone. Your body is pushing down with a force called weight, and that's being created by gravity, a force from the centre of the Earth. Have you ever thought about why things fall when we let go? What is the force that makes this happen? It's one of the big forces we can't see. It's called gravity. Gravity is the force which makes things fall to the ground if you drop them. It's actually a force acting from the centre of the Earth, pulling us towards it. What happens to something that's moving when you stop pushing or pulling it? Does it carry on going? Does it stop immediately? What is it that affects its progress? People have been puzzling over this for hundreds of years. Isaac Newton was a British scientist who lived in the 1700s. He worked out that an object will stay still, like this space rocket, until a force acts upon it. This is now known as Newton's first law. When the engines fire, the rocket lifts off and it changes speed in the same direction as the force which is acting on it. That's Newton's second law. There is a tremendous upward force on the rocket from the burning gas streaming downwards out of the engines. Newton's third law states, for every force or action, there is an equal force to act against it. Watch this experiment closely. You can try it in the playground. 2 people on rollerblades touch hands and push. What forces are in action to get this result? One person takes off the rollerblades. What's going to happen this time when they put their hands together and push? Watch this girl on her bike. First, she's standing still. Then she moves off by pushing on the pedals. And work out which of Newton's laws are in operation. What about this? Jack catches a ball and moves backwards. What forces are acting upon him? And which of Newton's rules explains what's happening? How objects move, or how difficult they are to move, depends on how smooth or sticky the surface is, or how much friction there is. Have you ever thought why the ball you kick eventually slows down? Why does the puck in ice hockey move so quickly on the ice? Why can you ski easily on ice but not on grass? Look at how the football rolls over the ground. And then how it runs over the grass. Do you think there's a difference? Goalkeepers often wear gloves with rough surfaces which help hold on to the ball. Can you think about why that should be better than using just bare hands? When one surface passes over another, there's a force called friction, which tries to slow things down. The smoother the surface, the less the friction, or grip between the two surfaces. Friction is sometimes called resistance. To resist means to try to stop. So friction tries to stop something that's moving. This may look like a polished floor, but if you looked under a microscope, you'd see lots of bumps like tiny mountains. Moving something across a mountain range is not easy. The bumps produce friction. What you wear on your feet can affect how much you slip on the floor surface as you walk. Which of these soles do you think will give the best grip? Think about which one would have the biggest bumps under a microscope.
My shoes don't slip because they've got a lot of grip.
My shoes sometimes slip because they're a bit smooth.
My shoes have got a good grip because they're rough.
My socks slip because they have no grip on it at all.
My feet must be rough because they give good grip.
Friction can be useful. If there was no friction, it would be impossible to grip anything. We'd slip and slide all over the place when we tried to walk or run. Soles of climbing boots or walking shoes have rough surfaces to increase friction, prevent slipping, just like car tyres and bike tyres. If you're riding a bike, you use your brakes to increase friction and slow down. The brake block pushes against the wheel rim and the friction on the wheel is increased, so it's more difficult for the wheel to turn and it stops. In the classroom, we decided to experiment with boats made of aluminium foil. The question was, how much weight could the foil boats carry? They're all made out of exactly the same size and weight of foil, so does it matter if they're different shapes? What do you think's going to happen?
I think my boat will hold more coins because it's got high sides.
My boat is made of double foil, so it's extra strong. Therefore, it'll hold more coins.
I think my boat will hold more coins because it looks more like a boat.
I think my boat will hold more coins because it has more room.
Watch what happens when each boat is loaded with coins. Shape 1,
2, 3, 4, 5, 6, 37, 38, 39, 40, 41.
Shape 2,
2, 3, 4, 5, 45, 46, 47.
Boat shape 3,
1, 2, 3, 4, 5, 35, 36, 37, 38, 65, 66, 67. 68, 69.
boat shape 4,
1, 2, 3, 4, 39, 40, 41, 42,
77, 78, 79.
So, what made the difference?
My boat won because it held the most coins and had the biggest area. The other three boats were roughly the same area and roughly the same amount of coins.
The area mattered, not the shape. We think the bigger the area, the more weight they can take.
That's the answer. The bigger the area, the more upthrust from the water to hold up the boat. So the more weight it can carry with the force acting in the opposite direction.
Although we're used to thinking of weight.
All right, so we're going to pause here. Most of what you've seen in the video should have helped you answer the questions. Now, there are a few at the very end that you should be able to answer on your own. So I'm actually going to stop sharing my screen now, and I'm going to transition back into Schoology, back to our video question and answers. So for your video question and answers, let me change my settings so you guys can see a little bit more clearly here. First, all forces can be seen. Well, that is false. Some examples for number 2, gravity, friction, magnetism. Number 3, when the engine fires, the rocket lifts off and it changes speed in the same direction as the force which is acting on it. This is known as Newton's second law of motion. Number 4, how an object moves or how difficult they move depends on how smooth or sticky a surface is. Number 5 was true. Number 6, another name for friction is resistance. Number 7, the smoother the surface, the less the friction or grip between the two surfaces. 8 is mass, 9 is Newton, and 10 is true. Please make sure you review these questions and answers. You also need to submit, but these would be fair game for a quiz or a test. All right, so now I'm going to go back to Monday's class because that's what this recording is for, and we're going to talk about types of friction mini poster. So after I go through the PowerPoint, you will complete a 4-section mini poster describing, explaining, and providing examples of the 4 types of friction. So you will take a sheet of paper folded into 4 sections, and you're going to title it with the 4 types, and those are sliding friction, rolling friction, fluid friction, and static friction. And then you're going to describe each of those and provide me with an example. You're going to submit your grade in a picture format. As in, you're going to take an image with your laptop of your work and you're going to upload, and I'm sharing my screen with you now so you guys can see a lot of people have already done their work and gotten that submitted. Okay, now at the bottom there is a PowerPoint that says types of friction PowerPoint. When you open that up, this is where you're going to get your information. Now, you may also do research if you want. If you don't want to use the examples that I have included here, you can use some other examples. Okay. Give me just a minute to change my settings so that you can see my PowerPoint. There we are. Oh, maybe not. Just a minute to fix my sharing, you guys. Let's try this again. Not really sure why my screen is not cooperating. Okay, so here we are. This should be a better view for you. So, types of friction. Let's discuss. Friction in general is a force that opposes between two surfaces. So anytime you're trying to move an object, push a box, do something like that, there's going to be friction occurring between the base of the object and the surface that it's exposed to. So the friction force would be at the bottom of this box, between the bottom and the green grass or green surface in the image here. Friction always depends on the surface. The video you just watched talks about that, right? If it's smooth versus sticky, the smoother it is, the less friction. The rougher it is, the stickier it is, the more friction. That's why the more bumps and grooves you have on the bottom of your shoes, the more friction that occurs between your shoe and the surface, and the less likely you are to slip. So here's some examples. If a car needs to stop at a stop sign, it slows down because friction is applied to the brake pads. If you run down a sidewalk and you stop, well, you stop, right? You don't go flying forward. And the reason you stop is because the attractive force or the force of friction that occurs between your shoes and the surface of the ground. So these are just some pretty simple examples. So now let's talk about specifics on friction. And we're actually going to skip over this video here, but I do want you to notice this little diagram here. Notice that friction as a force is always opposite the direction of motion. So if you're pushing a box towards the right, following the purple arrow, then friction is always going to be going the opposite direction towards the left, for example. So the first type of friction is sliding friction, and the name implies exactly what it is. It refers to the resistance created by two objects sliding against each other. An example is also rubbing your hands together, going sledding, going down a slide, pushing a box across a flat surface. Anytime you have two objects sliding past each other. The second type of friction is rolling friction, and this basically is going to occur between circular objects and the surface. So rolling friction involves a wheel, a ball, a bike tire, a lawnmower tire, something that is actively rolling, and that's the resistive surface between the rolling object. And in this example at the bottom, you can see there are some rollers, and the box is being pushed across the rollers, and the frictional surface is occurring between the surface of the rolling object and the bottom of the box. The third type is what we call fluid friction. This includes air and water. It's difficult for us to understand or to picture or visualize air as a fluid, but it is. So the fluid and air around us, that exist around us all the time, can cause friction. So airplanes, for example, have to overcome the force of gravity and the force of fluid friction caused by the air in the atmosphere. If you go swimming in a pool or the ocean, you experience fluid friction more. So as you swim through the water pushes back against you, and that is called fluid friction. So the interactive forces between your body and the water as you try to move is fluid friction. The fourth type of friction is called static friction, and we've all probably experienced this before. If you've ever tried to push or move a heavy piece of furniture or a heavy book or a heavy object, sometimes when you initially apply force, it doesn't move, it just kind of sits there. And then you kind of push a little bit harder, you try again, and all of a sudden the object will just start moving. This is an example of static friction. So the the force of attraction between a non-moving object is static friction. So it basically is kind of preventing two surfaces from sliding past each other. Eventually you can overcome static friction, and then usually if you're pushing an object, you transition from static friction into what we call sliding friction, or the example we used on the opposite, or the example that we had on that first slide. So again, static friction prevents an object from moving when a force is applied. So this is that little resistive force you might experience if you're trying to move an object. All right, so there are some videos embedded here if you would like to watch them. Otherwise, we're going to break there, and I'm going to go back into Schoology, and I'm going to explain to you what you need to do for the rest of this assignment. So your job now is to create that foldable. So this is kind of in lieu of or an alternative to formal guided notes. So again, you need to title it, fold it into 4 sections or draw lines, separate it out. Then you'll need to title it with friction. The 4 types, describe them, maybe sketch a picture. Doesn't have to be anything fancy. You could even show a square object going down an incline, sliding friction. Or you could show a circular object rolling friction, okay? And then the last thing is you'll also need to define friction in general. And then when you have finished, you are going to submit this for a grade. This will count as a 20-point classwork grade. So if you haven't done it yet, I will still accept it late, but you have to get it done. All right, so make sure you get that done. If you need any help or you want to download the PowerPoint, you can. That's there for you. Otherwise, you have everything that you need to be successful in this assignment. Also, please remember that there will be a test, your first major grade, Thursday, February 4th, first major grade in this class. All right, so that's it for Monday's lesson. I will upload Tuesday's lesson probably on Wednesday. Have a good day, and I'll see you guys in class. Bye, everyone.